Hi guys, welcome to my channel. So today's video we're going to be looking at the Cobb-Douglas utility function. Here I have written down a very basic form of the Cobb-Douglas production function. So from here we're going to be taking the partial derivative with respect to capital and labor. We're basically going to be finding the marginal product of capital and labor. To start, it's important to note that the exponents above the factors sum to 1. All right, so A would be a constant, K would be for capital, and L for labor. So if you're familiar with the Cobb-Douglas production function, you would understand that part of what I said just now. All right, so what do I mean by the exponent sum to 1? So let's do the simple math for it. So we have A plus 1 minus A, and then we should do the math for that. So simply A will cancel A right here, and then that will leave us with equal to 1. So that's as simple as it goes. So for example, let's say that alpha for capital is equal to a half. So we have a half plus a half should equal to 1. If alpha is equal to 1 over 3, a third, 1 over 3, so then 1 over 3, and then 1 plus 1 minus 1 over 3. This portion here will need to be 2 over 3 in order for the sum to be equal to 1. I'm sorry, so this should be equal to 1. Okay, so let me go ahead and erase this real quick. So there are several other principles that we're going to be using to make it a lot less complicated. So if you're familiar as well with the log rules, so the power rule for log when you're doing derivative would be 2 raised to the power of 2 is equal to 4, and that is a constant. So that would be a separate rule from what we're looking at. For this rule, if we had n raised to the power of 2, we take the power down in front, and then we minus 1 from the power. So let me use 2 separate colors to differentiate what we're doing. So let's say another example would be, in fact, let's continue with this one. So this will then becomes 2n, and then this is be 2 minus 1. 2 minus 1 is simply 1, and then 1 will just equal to 2n. That's one example. So to start, we've already discussed that the exponents should naturally sum to 1 in any given Cobb-Douglas function. All right, so we're going to be starting with the derivative of y, the y function, with respect to capital K. How do we denote this? So we denote this by saying this function is taking the derivative, and we're taking that derivative of the function, the y function here. So we write the y function, and then what are we taking the derivative with respect to? So because we're doing it with respect to K, we're going to be taking the derivative with respect to K. There you go. So that's the first start. So we need to be able to tell when you're reading this, what function are we differentiating? The y function. Fine. In the y function, what are we differentiating? We're differentiating y with respect to k. This is what this means right here. So now we're going to equate that to the derivative with respect to k, and we're looking at the y function. So from there, what we're going to do now, we're going to substitute what y is equal to. Y is equal to here, which is the a constant. So a times capital, which is k, raised to the power of alpha, times labor, which is L, raised to the power of 1 minus alpha. All right, so we're just going to simply write this portion of it right here that we have. So this portion into right here, okay? So this will become the derivative with respect to k, and then y is equal to a for the constant. So now that we have that written there, now we can go ahead and start to apply the power rule to start or to take the derivative. So we're going to take this alpha, which is the power here, in front of the entire function to start. So let's go ahead, alpha And then we're going to write back the function for that portion. And remember, alpha remains and we just minus 1. Because we're not differentiating L, we're going to rewrite this with the same power that it had. 1 minus alpha. Fine. So now that we have the function looking like this, what else can we do? Well, we can go ahead and separate this part of the function here. So this will become alpha k raised to the power of alpha, and then k raised to the power of minus 1. And I think I need to give myself some more space, so forgive me. Let me go ahead and fix that real quick. And then we're going to rewrite the labor portion. 1 minus alpha. Fine. All right, so from here, what else can we do to make this look a lot more friendly? Fine, we have k raised to the power of minus 1. This portion can also be written as 1 over k. And then we're going to be multiplying this, which is this, by the rest of what is in the function. So that is times alpha, a, the constant for a, and then alpha raised to the power of k, L 1 minus alpha. Okay, so from there, now we can put this entire function over k. So let's do that real quick. I'm taking all these steps just to make it as simple as possible. So let's go ahead. So this is going to be alpha. Let's rewrite that real quick. And this is all over k. So now I want you to take a close look at this. If you realize, now we have this portion here. The question is, what is this? Awesome, you got it right. That portion there, this is equal to what we have here, which is y. So now we can write this and substitute y, because we know from the start that y is equal to a times k. So the constant times k raised to alpha times labor raised to the power of 1 minus alpha. So let's go ahead and write that in. So this becomes alpha y over k. So that is it. This right here is also equal to the marginal product of capital. This is the value of an additional unit of capital. So that's the marginal. Let's go ahead and write that in. Marginal product of capital. All right. And another equation that you might also find useful, let's go ahead here, would be the rental rate of capital, the nominal. So let's go ahead, rental rate of capital. Let's go ahead and quickly write that. I'm just going to put K for capital, and that's going to be equal to price times, just in case you need this, it's going to be price times the marginal product of capital, okay? So that's the MPK. Oops. All right, and then the real rental rate will just simply be R over P, which is also equal the marginal rate of product. All right, so let's go again. Real rental rate of capital. I'm just going to leave it there for simplicity. To leave it as K, sorry. So it's equal to R over P, which is the MPK. So that is how we take the derivative of y with respect to capital. We're going to do the same with respect to labor. So now we're going to be taking the partial derivative of y with respect to L. So if you want to stop to pause right here and try to approach it by yourself, feel free to go ahead. Otherwise, feel free to follow as well. All right, so again, we're going to start by what are we differentiating? We're differentiating the y function with respect to labor. All right, so let's go ahead and write that. So that is what it should be. Fine. That will now become, so now what we're going to be doing, we're going to be substituting what y is, which we have here. So this becomes the differential with respect to L times the constant times K raised to alpha times labor 1 minus alpha. So what we can do to make it as simple as possible, we're going to go ahead and bring the power down for L. So I'm going to use two different colors to not make it complicated. So the power for L would be 1 minus alpha, right? And we're going to treat this as a constant. So we're going to write back A, K, alpha. See what I mean? And then now we're going to differentiate. Because we're differentiating L, we're going to write L 1 minus alpha. And then we're also going to be minusing 1. That's the power rule. Don't confuse yourself. That's just the rule, okay? So from here, now what you will see, we can now separate this portion like we did before. So we're going to have 1 minus alpha. Rewrite this as a constant. And then we're going to have labor raised to the power of, come on, you got this. Correct. 1 minus alpha. And then labor also raised to the power of minus 1. This too can also be written as, there you go, 1 over L. Now that you have that portion right there, 1 over L, or if you want to keep the order as you had it before, that's perfectly fine. Let's do it that way, because some of us might just be able to work things as you go across, Okay, so fine, if that's your method, let's do it that way. Let me go ahead and rewrite it for you. 1 minus alpha. Again, this is a class where we make everything in math for econ very simple. So rewriting this just for you to see the steps, and this becomes 1 minus alpha, and then this is 1 over L. Right? So this portion minus L raised to the minus 1 becomes 1 over L. All right, fine. Now that we have that, what can you see? What do you see is happening? Slowly we're getting something that looks like, well, we already have something that looks like the y function, which is this portion here. And again, we can also put this entire part of the function over L. So let's do that to make it consistent with what we did before. But then again, we are at the same junction. What is this? We're at a similar junction. Let me not say same. What is that function there? And you're absolutely correct. That is equal to the y portion. This is equal to y from here. Okay, so now that we have this to be equal to y, what can we do with that information? Yes, we can go ahead. 1 minus alpha times y over L. And there we go. That would be the marginal product of labor. That's the per capita production. All right, so this here is equal to the marginal product of labor. There you go. And a simple equation that you also would like to remember as well. So we're looking at the wage. So wage, let me go ahead and write it here real quick. So wage will be equal to price times MPL, marginal product of labor. Real wage would be equal to, Come on, you got, okay, let's go ahead. So that will be W, what is W? Wage over price times the MPL. And before, when we did the capital, I didn't mention that the R that we had was the rental rate. All right, so bear that in mind. So there we have it. We were able to successfully find the partial derivative of y with respect to capital and labor. So thank you guys, and see you in my next video where we make econ math simple.